Today we're talking about samples and surveys, and I would say that this is not like normal math. It's more conceptual, so there's not a lot of calculating. You won't really need a calculator at all for this. So just gotta be prepared. It's a little different than normal math. So first, just let's define a few terms. So a population is a group of folks. It could be like all the girls at St. Mary's, right? And then I take a sample of those girls. So maybe I take a small sample. Hopefully, all statisticians would always randomly sample rather than just choosing who I want to ask. You want to make a random selection, select a sample, and then ask your survey question, or figure out what's your favorite band, or whatever the question is. And maybe we could infer something about the population if we have a representative sample. So representative sample is hard to get because if I was trying to find out, say, the favorite band of everyone at St. Mary's, well, say in the high school, if I only surveyed ninth graders, that might not be a representative sample. Maybe 12th graders have a different taste in music than ninth graders do. And so you want to try to get a kind of a cross section of different, well, if there's different genders, but not in that case. Um, different ethnicities, different ages, grades in this case, a school. So you want to get many, many different types of folks and have a nice representative sample there that we can ask our question to and maybe find out more about. So there are a few ways we can do this. So one way is to, and this is a really good way, is random sampling. Statisticians, we love to do things randomly. So this is not one way of doing this would be put everyone's name in a hat in St. Mary's or something and draw names out of the hat randomly, just kind of select them. The key idea here is that each element of the population has an equal chance of occurring, so of getting picked. So you have the same likelihood of getting picked for the sample as anyone else at school. Convenience sampling. So in convenience sampling, you are going to just choose whatever's easy. So it might be just I'm standing outside my door and there's 4 or 5 people congregated around my room. And so I start asking them questions. Hey, what's your favorite band? What's your favorite type of fruit snacks or something? And hopefully Erin Monroe is, one of the folks so she can be really informed about that question. But that would not be fair just to ask whoever was just close by, and that's not a very good random sample, and so it's not a very reliable way of sampling. But that's one way of sampling is just convenient, whoever's closest by. So systematic is a little bit better. It's right up there close to random sampling, and that's just like every nth person. So if I was, in class, every third person to walk through the door gets asked the question or something. So you're standing outside a supermarket. Every 10th person to walk outside the door, you ask them a question. So that would be a systematic way of sampling, and that's pretty good actually. This one is really not looked at very highly by statisticians, but a lot of folks do this. You see this a lot with internet polls, or you see just, hey, would you volunteer for this? Select only people who volunteer, that being a key word there. And it's not a very reliable sample. For example, like an internet poll, if you were to ask a question about, do you think, say, the Grizzlies are the best basketball team? Well, if you're from Memphis, you might kind of like self-select yourself and say, "Oh, I do. I think they are the best basketball team," and you might click yes. If you're from, Seattle or something, you may go, "Well, I don't really care about this question. I'm not going to answer it." So you might get people who feel very strongly one way or the other about a certain issues. And so it's not necessarily a representative sample of how people really feel about the Memphis Grizzlies basketball team or something like that. And so you want to avoid a volunteer type of sampling method. It's not a very reliable method. So let's look at some examples and maybe we can kind of like figure out which sampling method is being used in each case. So a newspaper article on a tax increase invites readers to call the paper and express their opinion. So if you look back to those, they say, hey, call us up and if you want to do this. Well, this looks like a self-selected sample, right? You're basically volunteering to be a part of this study by saying, hey, I'd like to participate in this. And so that's a self-selected sample, not a very good way of doing things. Reporter interviews people leaving the city's largest park. Let's see, what would that be? Did they randomly do it? Is it more convenience? Is it systematically doing it? Just kind of interviews people. So this seems like a kind of a lazy way of doing things, just a convenience sample, not very effective. There's a lot of people there, so it's easy to interview a lot of different people, but not a great way to do things. A survey service calls every 50th person in the phone book. Well, that seems like, they've thought it out through. That's a very systematic way of doing things. That's a systematic sample. And so usually you can kind of like categorize what type of method you're using to sample people. Studies. So when we do a study, you're studying the effect of, the new vaccine or something for some type of illness. Or it could be anything really. So observational study, you might be, trying to figure out what's the best way to teach online or something. So one way is just to observe members of the group. So members of a sample, sorry, I think I misspelled that, in such a way that they are not affected by the study. So you're not really asking them questions. You're just kind of like an observer, kind of like a fly on the wall. Maybe you have a glass, window. You can see your videotaping, but you can't really interact with people. So this is just an observational study. You're not affecting anyone in the room. You're not really asking them questions. You're not, giving out, drugs to cure their illnesses. It's just an observational study. And that's just you're observing. Now, a controlled experiment, quite a bit different. And you see a lot of this in psychology, really a lot of different things, certainly medical trials and things. So that the things you have to divide them hopefully randomly into groups. You impose a treatment on one group. So let's say this was a high cholesterol study. So everyone in the study maybe has high cholesterol. And so what you do is you divide them into two groups. One group randomly. One group is given the real drug. So you are testing out a new drug for cholesterol. You give them the real drug. These little, green pills or something. And then the placebo is something that you give the other group. So the other group thinks they're taking the real medicine. They think they're part of this trial. I guess they are, but they're the placebo group. They're called the control group. And so their pills look the same. They might be the same little green pill, but it's like a sugar pill or something. It's not something that has really any effect on anything. So it doesn't have any of the things to lower your cholesterol. What happens though, there's something called the placebo effect. And so they think they're taking a pill that's going to get them better. And so sometimes they're making better life choices or just the mental, think, hey, I'm taking this pill. It's got to help out. Maybe my cholesterol will go lower. And maybe it does. Usually the placebo effect has a slight positive impact on people who are part of a study in the placebo group. However, when you compare the two results, what you're hoping for is that the treatment group will have a much larger reduction of cholesterol or whatever it is you're studying. And so you want to compare the placebo group to the treatment group. You want to make sure that you're not, placebo group may not have zero effect. It's probably have some positive effect usually by taking that placebo pill. But you want to be able to compare. Well, hopefully your drug you're testing has a much bigger effect on the group. And you can say, hey, this drug is really effective. We're going to keep giving out this drug to people. And survey, you ask every member of a sample a set of questions. So this is one, you've seen surveys, you might have participated. I think I was in a mall once shopping and they said they'd give me like $15 to answer some questions. I said, sure, I'll answer some questions for $15. And so I self-selected, I guess, and answered their questions. And so in this case, a survey is hopefully you want to ask every member of the sample, ideally, to be part of that survey. So bias. So bias statistically is when you favor one outcome over another. And you'll see this. This happens quite often. In fact, when you watch the news and you see results of different polls, once you know statistics a little bit, you kind of be like, well, I don't really like that question. It's not a fair question. And so you want to be very fair as a statisticians, and so you want to be very careful about wording a question the right way. And sometimes we don't word things very well. This question may not be worded the best. It says, do you think farmers should use poison to control insects on crops? And sometimes we refer to this as a loaded question, but you really need more neutral wording here. Like use words like pesticide instead of poison. Poison implies, it just has some bad connotations to that, and you're going to get people go, oh, yeah, that doesn't sound, we shouldn't use poison. But pesticide, oh, well, I guess we should use, you might have it. I'm not saying you definitely would agree, but it seems like a more neutral or fair way to ask that question. And so using a word like poison would cause bias in this question. Don't you agree that everyone should wear masks when they go outside? So this is kind of don't you think that seems like kind of a leading question, right? Don't you agree? Like if you don't agree, that puts you in the minority, it almost sounds like. And so that would have a bias to it. You're trying to get a certain outcome. You're favoring one outcome or another. Just like that first question, you're trying to get them to agree. Hey, to use poison? Yeah, that sounds bad, right? Do you think that teachers should communicate frequently with students and their parents about their grades? Boy, that sounds like a great idea, right? But what's not fair about this question? This seems fair, doesn't it? But if you look at it closely, actually, there's two issues in one question, and that's kind of a no-no. Really, we're talking about communication with parents and communication with students. Those are two different things. You might be for communicating with students, but maybe not communicate with parents unless it's certain situations and you felt like it was okay then, or something. I'm not sure, but they're two different issues in one question. So you don't want to have that kind of muddies the water. Keep it simple. If you want a good question that doesn't have a lot of bias, keep the question on the simple side of things. So last thing, let's just design a quick survey. So during the 2008 Olympic Games, a U.S. swimmer, you might know who it is, won more gold medals than any other swimmer had ever won. What sampling method could you use to find the percent of students in your school who recognize a swimmer from the photograph? Well, I mean, you could use a lot of different ones. You might randomly select. So you could put everyone's name in a hat, kind of like randomly select some of the students to ask them. You could do systematic. These are both be good ways of doing things. So you could use, every 10th person that walks into the school, you ask them, show them a picture, say, ask them a question, etc. So there's a number of good ways. Convenience sampling or volunteering is not a great way of doing it. What is an example of a survey question that's like to yield information that has no bias? So again, keep the question simple. Maybe something like, who is pictured in the photograph? So don't, kind of lead them to an answer, favor one outcome or another. That would be incurring bias. And so that's just the idea of designing a survey that seems fair. Statisticians, mathematicians are pretty fair. And so we try to be fair and random when we're mathematicians and use good surveys and samples and so forth. So that's the lesson for today. Thanks.